Hi everyone, I'm Jack Ramos and I'm here with the subject matter of conditional statements. Conditional statements are the classic if-then statement. I'm sure you've seen these guys before. We'll be going more into depth about the logic behind the if-then statement through a truth table. In this example, if P is true, then Q is true. Imagine with me a scenario. You're sitting with your friend. You're by a lake and you both see a bird on a branch over the horizon. You turn to your buddy. Bet you that if I hit that bird with this rock, then it will fall. The hypothesis, your bet, representing P. The outcome, whether it falls or not, represents Q. So your friend wants to make sure they get their money. They clarify the bet. If you hit the bird, then it lands, you get $5. True. If you hit the bird, then it flies away like nothing happened. I get $5. False. You two shake on it and you chuck that rock at the bird with gusto. Instead of even landing the shot, you miss and the bird flies off. Now, what does this mean in terms of a conditional statement? If your hypothesis P wasn't true in the first place, or false, well, your friend says the bet is his because you couldn't land the shot in the first place. Has a sore loser. In conditional statement sense, because we couldn't prove that the hypothesis was false, we have to assume it was true due to vacuously true statements. We have to give it the benefit of the doubt that there really isn't anything distinctly and clearly proving it wrong. Think of innocent until proven guilty. Here's another example of logic. I'm going to use the example directly from Dr. Trefort-Bazet. I really enjoy his example for how concise and clear at demonstrating this. If I study hard, then I will pass. If we had to break this phrase down, it would look a bit like this. This is equivalent to this. This is also equivalent to this. Now let's picture the opposite of this phrase. Again, I love the phrasing of this. The inverse of P would be portrayed in a sentence like, either I don't study hard or I pass. Negative P, positive Q. Here we can see that if positive P, then positive Q is logically equivalent to if negative P, then positive Q. Shout out Dr. Trefort-Bazet. Thank you for watching.